Welcome everyone. Today in this video I will show that if we have two lines that are perpendicular to each other, then the product of their slopes gives -1. So let me visualize what I just said. Let's say that we have an xy plane like this. This is x and this is y, and we have two lines. Maybe this is called line 1 and this is line, actually I will make this picture a little bigger. I will do it again, but let's just keep it this way for now. And we have L1, L2, and just like I said, they are perpendicular to each other. So in this video our goal is to show that if we multiply their slopes, and for slope we just use m, when we put a subscript it means in this case the slope of the first line. If we have m1 times m2, it is equal to -1. If, actually you could say if and only if, L1 and L2 are perpendicular. This symbol right here means that they are perpendicular. So how could we prove this? To start our proof, as I said, I will make the picture greater. So let's have it drawn like this, and we have axes again, right? So we have two lines. Again, this is x, this is y, and I will just call them by their slopes so that it will be easier for us to keep track of, m1 and m2. If they are perpendicular, if this is a right angle, then, and by the way, obviously there are different ways of representing right angles. You could just put a box, and I prefer to put a dot inside the box to represent a right angle. This is the convention that I am using, so keep that in mind. We have alpha and beta here. We know that since the interior angles, the sum of the interior angles of a triangle is equal to 180 degrees, it means that alpha plus beta is equal to 90 degrees. And also this angle right here is equal to 180 degrees minus beta, obviously. So how can we prove this statement? Well, to do that we need to think of the slopes as tangents of angles. So in that case, m1 will be the tangent of the angle that line 1 makes with the positive x-axis, positive horizontal axis, which is alpha. And for m2, we will have the tangent of the angle that it makes with the horizontal axis, with the positive horizontal axis, with the positive direction. So this angle right here, not beta, but 180 degrees minus beta. Of course, using the definition of tangent function, we can represent this second slope as sine of 180 degrees minus beta divided by cosine of 180 degrees minus beta. So the only thing left is to just multiply m1 and m2 and to see whether or not they give whether or not that multiplication gives -1 as its product. So let's do that. And let's write with, I don't know, green maybe. Let's separate our workspace. Yep. m1 times m2. It will be equal to tangent of alpha times sine of, and well, actually I want to put everything in terms of alpha, so let's do it real quick here as a thought bubble, maybe thought bubble. We have this inside of the sine and cosine for the second slope. So if we substitute for beta here, we would get, well, beta is equal to 90 degrees minus alpha, right? It is equal to 90 degrees minus alpha. Oops, not alpha degrees. Alpha is already an angle in terms of degrees. So if we distribute the negative sign, we get 90 degrees plus alpha. Great, so that is what we will use. And as I said, this is a separate calculation as well. So now for the argument of sine, I am writing 90 degrees plus alpha. And for cosine, I am writing 90 degrees plus alpha. We have tangent of alpha times. Let's use some formulas for sine and cosine here. So the sum formula for sine will be, we have sine of 90 degrees times sine, well, not sine actually, cosine of alpha plus cosine of 90 degrees times sine of alpha. As I said, this comes from sum formula for sine, and now using the sum formula for cosine, we will have cosine of 90 degrees times cosine of alpha minus sine of 90 degrees times sine of alpha. And there are some simplifications that we can make. For example, cosine of 90 degrees is equal to 0, so this term goes to 0. And here as well, it goes to 0. Also, sine of 90 degrees, this and this, these are equal to just 1. So we will have tangent of alpha cosine of alpha divided by negative sine of alpha. Well, what is tangent? Just like we said a couple of minutes ago, it is sine of alpha times cosine of alpha. So we have these, and what happens? Sines cancel, cosines cancel, we are just left with a negative sign, so this is equal to negative 1. What is equal to negative 1? Well, the product of the slopes. So we proved that if we have two lines that are perpendicular to each other, then their slopes give negative 1 when we multiply them together. I hope this video was helpful. If you have any suggestions or questions, please write them in the comment section. I hope to see you in another video. Until then, take care.